Hi everyone, welcome back. We're going to look at another application problem, optimization application problem. So let's just get started. So the rectangular pig pen using 300 feet of fencing is built next to an existing wall. So only 3 sides of the fencing are needed. What dimension should the farmer use to construct the pen with the largest possible area? Alright, so I'm going to draw myself a picture first. So I've got this wall. I'm just going to say wall, alright. And I've got some fencing. So it looks like something like this. Now your picture may look a little different, your wall may be on a different side. This is just how I'm going to visualize it. And so it's a rectangular pig pen, right? So that means that this is my length, some x, and this is my width, which is the same on both sides. Alright, so first thing is they tell us about the fencing. So what do we know? We know that the fencing is 300 feet, but it is also the length of the sides, right? So what is the length of the sides? It's y plus x plus y. So it's going to give me 2y plus x. That's the length of the fencing. Okay? Alright, so what else do we want? It says, what dimension should the farmer use to construct with? Okay, so largest possible area. So now we've got to look at area. So the area of this shape, it's a rectangle. So remember, area is equal to length times width. So the length in this case is my x, and the width is my y. Alright, so go back to the boot camp notes. Remember, when we're doing variable modeling, you don't want to have 2 different variables going on at the same time. It makes it a little bit harder, so you want to rewrite everything in terms of one variable. And so what I'm going to do is I'm going to take this information that we have here, okay, so remember 2y plus x is equal to 300, right? That's my fencing. And I'm going to rewrite it so that when I'm dealing with area, and before I even differentiate the area formula here, I'm going to make sure the area is represented with one variable. So what's the easiest one to solve for? Well, if I have 300 equals 2y plus x, I'm just going to subtract 2y on both sides so that I know that x is equal to 300 minus 2y. So I'm going to replace this x with this. Okay, so I have my area is equal to my new x, which is 300 minus 2y times y. And you could do it the other way too, it's just I don't want to have to deal with fractions and all that. So let's simplify this a little bit further before I differentiate a little bit. So let's see. Area is equal to 300y minus 2y squared. Alright, so we're looking for the largest possible area, right? So let's differentiate here. So a prime is equal to, if I take the derivative here, 300 minus 4y. Okay, and because we're looking for the largest possible area, we want the derivative to equal 0. So we're going to solve this, and let's see. I get 300 is equal to 4y if I bring the 4y over, and I get 75 is equal to y if I divide by 4. Alright, great. So remember, we're looking for the dimensions. So if we look back at our picture, what we found is the width. So we know now that this is 75, right? And so is this side over here. We need to find our x. So we're going to use what we know. We know that x is equal to 300 minus 2y, so let's use that. So x equals 300 minus 2y. So I'm going to substitute that y in now. And I get x is equal to, what is that, 150. So what are the dimensions that the farmer should use to construct the pen for the largest possible area? It should be 75. And what unit are we in? 75 feet, I'm assuming, right? Yep, feet by 150 feet. So that is the dimension that he should use to have the largest possible area.